If you're new to quantitative analysis, one of the first terms that you'll likely hear thrown around is descriptive statistics. In this video, we're going to break descriptive statistics down using plain language and loads of examples that you can approach your analysis with confidence. Let's do it. So let's start by first asking the question, what are descriptive statistics? Well, at the simplest level, descriptive stats, or just descriptives, are a way to summarize and describe relatively basic but essential features of a quantitative data set. For example, a set of survey responses or sales data for a specific product. Descriptives provide a snapshot of the characteristics of your data set and allow you to better understand roughly how the data is shaped, and we'll speak more about this a little bit later. This probably sounds a bit conceptual, so let's take a look at some examples. A basic descriptive statistic could be something as simple as a count of the total number of survey participants, in other words, your sample size. Taking it a step up from there, the proportion of males and females within that survey sample would be another descriptive statistic. Similarly, you could calculate the percentage of people that answered a specific question within the survey, and that too would be a descriptive statistic as it describes an attribute of your dataset. These are all very basic calculations, but as you can see, descriptive stats such as counts, percentages, and proportions will give you at least some insight into the composition of your data and help you interpret that data in context. Now, you may have also heard the term inferential statistics being thrown around, and you're probably wondering, how's that different from descriptive stats? Well, simply put, descriptive stats describe and summarize the data itself, while inferential statistics use the data from a sample to make inferences or predictions about a larger population. Put another way, descriptive stats help you understand your sample, while inferential statistics help you make broader statements about the population based on that sample. If the concepts of samples and populations sound a little bit foreign to you, don't worry, we've got an explainer video covering exactly that, and we'll include a link in the description. Now, it's important for me to say that while descriptive stats are relatively simple from a mathematical perspective, they play a really important role, regardless of whether you're using them in combination with inferential statistics or not. There are at least two reasons for this. The first reason is that descriptive stats allow you to quickly identify potential issues within your data set. For example, suspicious outliers, missing responses, and so on. Naturally, it's really important to spot these kind of issues and address them as soon as possible, and so descriptives help with exactly that. The second reason that descriptives are so important is that if you are planning to use inferential statistics, your descriptives will inform that decision-making process. This is because each inferential test has specific requirements or assumptions regarding the shape of the data. If you use an inferential technique that your data set is not suitably shaped for, the results will be meaningless. And so you need to dig into your descriptives to understand what the shape of your data is before you move on to inferentials. All right, with the what and the why out of the way, let's take a look at the most common descriptive statistics. Beyond the basic counts, proportions, and percentages that I mentioned earlier, we have what we call the Big 7 descriptives. These can be divided into two categories: measures of central tendency and measures of dispersion. Let's start with the former. True to their name, measures of central tendency describe the center or middle section of a dataset. In other words, they provide some sort of indication of what a typical data point looks like within a range of numbers. The three most common measures of central tendency are the mean, the median, and the mode. The mean is simply the mathematical average of a set of numbers. In other words, the sum of all the numbers in a range divided by the count of all the numbers in that range. The median, on the other hand, is the middlemost number in a range of numbers when those numbers are arranged from lowest to highest. Lastly, the mode is simply the most frequently occurring number in a set of numbers. To make this all a little more tangible, let's take a look at a practical example. Here we have a sample data set that reflects the service ratings on a scale of 1 to 10 for a specific business from 15 customers. As you can see, the mean of 5.8 is simply the average rating across all 15 customers. In other words, the sum of all ratings divided by 15. Next, we have a median of 6. In other words, if you were to list all the responses in order from lowest to highest, customer number 8 would be right in the middle, with their service rating being 6. Lastly, let's look at the mode of this data set, which is 5, as 5 is the most frequently occurring rating, appearing 3 times in total. So as you can see, these 3 descriptive statistics, that's the mean, the median, and the mode, give us a quick overview of how customers feel about the service levels at this business. In this case, the descriptives reveal that most customers feel rather lukewarm, and there's certainly some room for improvement. From a more statistical perspective, though, this also means that the data tend to cluster around the 5 to 6 mark, since the mean and the median are fairly close to each other. To visualize this, let's take a look at a frequency distribution of the responses. As you can see, the responses tend to cluster towards the center of the chart from 4 to 7, creating something of a bell shape. In statistical terms, this is called a normal distribution or a bell curve. As you dive into quantitative data analysis, you'll find that normal distributions and bell curves are very common, but they're certainly not the only type of distribution that you can get. In some cases, data can lean towards the left or towards the right of the chart. This lean is measured using a statistic called skewness. If you look at these 3 distributions, you can see how different mean, median, and mode combinations will affect the skew or the shape of a distribution. Now, as I mentioned a bit earlier, the shape of your data is really important because it'll impact what you can and can't do in terms of inferential statistics. So be sure to pay very careful attention to the skewness statistic whenever you're looking at a data set. All right, so now that we've looked at some of the common measures of central tendency, let's move on to measures of dispersion. As we've seen, measures of central tendency provide some great insights into how centered a data set is, which is, of course, very useful, but it is only half of the picture. Beyond centeredness, it's also important to understand how dispersed any given data set is. In other words, how tightly or loosely the data cluster towards the mean, that's the average. This is really important to understand because it impacts how you interpret the mean. If the vast majority of the data are tightly clustered around the mean, then the mean statistic will provide a relatively accurate representation of the center of the data. On the flip side, if the data are scattered all over the place, if they're really dispersed, then the mean becomes a bit less meaningful, and you need to interpret it with some caution. Now, let's put the theory aside for a moment and look at 3 popular measures of dispersion. First up is the range, which simply measures the difference between the largest number and the smallest number in a dataset. Naturally, a high range means that there is at least a possibility of the data being quite spread out, being quite dispersed. But that's not a certainty because it could just be the result of 1 or 2 outliers. To get a better picture of that spread, we need to look at another measure of dispersion, which is the variance. And variance measures how much each number within a data set varies from the mean. More technically, it calculates the average of the squared differences between each data point and the mean. If that sounds like gibberish, don't stress. All you really need to appreciate here is that a higher variance indicates that the data points are more spread out, while a lower variance suggests that the data points are closer to the mean. Last but not least, we have standard deviation, which is simply the square root of that variance statistic that we just looked at. Standard deviation serves the same purpose as variance, but it's a little bit easier to interpret because it presents a figure that's in the same unit as the original data. You'll typically present your standard deviation statistic alongside your means when you describe data within your research, because this helps the reader interpret that mean within context. This probably all sounds a little bit conceptual and mathematical, so again, let's look at our sample data set to make things a little bit more tangible. As you can see here, the range of 8 reflects the difference between the highest rating, 10, and the lowest rating of 2. So right away, we can see that there is at least some possibility of this data set being quite spread out, as 8 on a scale of 1 to 10 is a pretty high number. We'll skip past the variance and look at standard deviation because these are telling us the same thing. And here we can see that there is a standard deviation of 2.18, which tells us that on average, results within the data set were 2.18 away from that mean of 5.8. This reflects a relatively dispersed set of data, which confirms what we can see in the bar chart. For the sake of comparison, let's take a look at another much more tightly grouped, that is less dispersed, dataset. As you can see here, all of the ratings lay between 5 and 8 in this dataset, resulting in a much smaller range, variance, and standard deviation. You might also notice that the data in this set are clustered toward the right side of the graph. In other words, the data are a bit skewed. If we look at the skewness statistic for this dataset, we can see a result of negative 0.12, and that reflects that slight lean. All right, so hopefully these examples help demonstrate how range, variance, and standard deviation all provide an indication of how dispersed a data set is. As I mentioned, these measures are really important because they help you interpret the measures of central tendency, especially the mean, within context. In other words, if your measures of dispersion are all fairly high numbers, you need to interpret your measures of central tendency with some caution, as the data are not particularly centered around that mean. Additionally, as I mentioned earlier, all of these statistics inform what you can and can't do in terms of your inferential stats, but we'll dig into that in a separate video. Okay, so we've covered quite a lot of ground in this video. Let's quickly recap on the key takeaways. Firstly, descriptive statistics, although relatively simple, hopefully you can now appreciate are an essential part of any quantitative data analysis. So don't skip over them in favor of the more exciting statistics. We looked at measures of central tendency, which include the mean, that's the average, the median, and the mode. And we also looked at skewness, which indicates whether data set leans to one side or to the other. And last but not least, we looked at measures of dispersion, which include range, variance, and standard deviation. All of these measures help you understand how dispersed your data are, and in turn, how to interpret your measures of central tendency. If you got value from this video, please do hit the like and subscribe buttons to help more students find this content. If you want to learn more about quantitative data analysis and the research process in general, be sure to check out the Grad Coach blog, where we have a huge collection of free resources, including detailed explainers, how-to guides, templates, and even some webinars. Alternatively, if you'd like hands-on help with your research, check out our private coaching service, where we guide you through each stage of the research journey, step by step. Thanks for watching, and until next time, good luck.